Now let us see the difference between angle of friction and angle of repose. First, the angle of friction. This is the case we consider that an object kept on a horizontal surface, whereas the angle of repose we will consider this situation in the inclined plane case. So let us see the difference between these two cases. First one, angle of friction, when an object kept on a horizontal surface like this. We know that two surfaces are in contact. The electromagnetic force between two surfaces is always resolved into two components. One is tangent to this surface, that is taken as frictional force, and other one perpendicular component we are taking as normal force or normal reaction. The resultant of these two, let us consider that the resultant of these two as capital R. Then the angle between this resultant and normal force or normal reaction we are taking as angle of friction theta, let us indicate. So the angle of friction theta, this is nothing but the angle between the resultant of normal force and frictional force with the normal force of this surface. So this is the angle of friction for this case. If this is the angle of friction, let us consider this triangle here. What is this triangle? Rectangle triangle if we consider. Observe, this component is capital R, resultant of frictional force with normal reaction. This is hypotenuse here. Let us take this is capital R, resultant, and this side if you observe tangential force, that is frictional force F. This is F here, and this component, this is the normal reaction or normal force here. Let us take this one, normal reaction, and where the angle of friction we have taken means R to N. So R versus N. So here we have taken this angle of friction. If this is a rectangle triangle, tan theta if I consider for this rectangle triangle, what is the tan theta for this triangle if you observe? Opposite side, that is F, divided by adjacent side, that is capital N, and we know that the frictional force is proportional to the normal reaction, and this proportionality constant is, let us take it as static friction coefficient mu s. So F is mu s n. Let us take this equation in this numerator, so that tan theta is equal to mu s and n divided by n, so that in this n cancels. We are getting that theta, the angle of friction, that is nothing but tan inverse mu s, the coefficient of static friction. So simply the coefficient of static friction, it is defined as mu s is nothing but tan theta. So the coefficient of friction is also defined as the tangential of the angle of friction, or theta angle of friction is nothing but tan inverse coefficient of static friction. So this is what the angle of friction here. Similarly, if you consider that angle of repose, this case we are seeing in the inclined plane case. Let us take a horizontal here, an inclined plane which is making an angle alpha here. With the horizontal, the inclined plane making an angle alpha. Let us keep an object on this inclined plane. First, we know that the weight of this object always perpendicular to this one. I mean perpendicular to the horizontal. So if this is the weight which is perpendicular component to the horizontal, this is of weight direction, that is, let us take it as mg here. If this is mg, let us resolve this mg into two components here. One is perpendicular to the inclined plane, another one is parallel or along the inclined plane. What we have taken, the components of this weight mg is, one is perpendicular to the inclined plane, other one is along the plane. Let us consider this situation. So this mg if I take here like this, observe this, this is making some angle here. What is this angle if we observe first? This is 90 degrees and this is alpha, and we know that this is a perpendicular component. Observe, I am plotting this one separately like this on this inclined plane. This is mg cos theta and this is perpendicular component of weight. Here alpha we have taken, that is inclination angle, inclination plane making an angle alpha with the horizontal, and Observe, this is the weight component direction, that is perpendicular 90 degrees. Now observe this is 90 degrees, and what about this angle means? In this triangle, total sum of the three angles should be 180 degrees. That means alpha plus this 90 degrees plus this angle, that is some x if you take, that should be equal to 180 degrees. That means what is the x value here? It is, that means it is 90 or 90 minus alpha it will be. So if this is 90 minus alpha, observe this total angle is 90 degrees. If this is 90 minus alpha, this should be alpha. Observe the angle between this weight component and this perpendicular component of the inclined plane. This is alpha, which is nothing but the angle between the inclined plane with the horizontal. Let us consider this situation here. For this triangular case, observe, this is alpha we have determined here. If this is alpha and this is mg cos theta, so this is the